Domain and range describe the allowed inputs and the possible outputs of a function. On the SAT, you read them from rules and you read them from graphs. If you mix them up, you can eliminate the right answer by accident. So we will anchor both words to direction on the graph. The domain is the set of x values you are allowed to plug in. The range is the set of y values the function can actually produce. For many nice functions like non-vertical lines, the domain is all real numbers until a rule forbids an x value. Two operations create most restrictions you will see on the SAT: division, which cannot use a zero denominator, and square roots of negative numbers in the real setting. Next, we will level up, a line with no walls, then a rationale with one x-hole, then a square root with both domain and range caps. Example 1. A linear function like f of x equals negative x plus 7. You can plug in any real x, so the domain is all real numbers. The range is also all real numbers, because a non-constant linear function eventually reaches every height as x varies. Example 2. A rational function. Let f of x equal 1 divided by x minus 3. The denominator cannot be 0, so x cannot equal 3. The domain is all real numbers except 3. On a graph, you will often see a vertical asymptote where the function blows up near that excluded x value. For range here, y equals 1 over x minus 3 can never be 0 because a fraction is 0 only when its numerator is 0. So you can have domain restrictions from x and separate range restrictions from y even in the same function. Example 3, a square root plus shift. Let f of x equal the square root of x minus 2 plus 1. The expression under the square root must be 0 or positive, so x minus 2 is greater than or equal to 0, which means x is at least 2. The square root itself is never negative, so the smallest output happens at x equals 2, where the square root is 0, and f of 2 equals 1. So the domain is x greater than or equal to 2, and the range is y greater than or equal to 1. Another range idea shows up with curves. Take a parabola that opens upward with vertex at the point 0, negative 4. The lowest output is negative 4 at the vertex, and the parabola rises forever upward. So the range is y greater than or equal to negative 4. That is the vertical span of the graph. From the minimum y upward, domain would still be read horizontally, and here it is all real x in the picture. Common mistake: you correctly find the allowed x values, then accidentally report them as the range, or vice versa. Remember, domain lives on the x-axis thinking. Range lives on the y-axis thinking, even when the question is purely algebraic. CTTT pro tip: if you're given a graph, scan left to right for the domain, because that is the x-span covered by the curve. Scan bottom to top for the range, because that is the y-span covered by the curve. If endpoints are filled in, include them. If there is an open circle, exclude that boundary value. Recap: first, domain describes legal inputs, x; range describes possible outputs, y. Second, rational functions exclude x values that make denominators 0. Third, square. Roots force the inside expression to be non-negative, and that can create both domain and range bounds. Fourth, on multiple choice, double check you did not swap domain and range at the last second. Practice more on NovaMaths.